So our next speaker here is Dr. Jacqueline Vadjunec from Oklahoma State University.
Thanks for inviting me. I'm happy to be here. When I was first invited, I was thinking, what do I have to say about this issue? I'm a mixed methods, participatory, human environment, muddy boots researcher. And so I was like, why am I being invited? And then I realized that I do have a few things to say about ethical dimensions of big data, replicability, and mixed methods and spatial analysis. So I'm going to talk about that here right now. So a bit about the outline. I'm going to talk about big data as the big data revolution is both an opportunity and a challenge. I'm going to talk a bit about accuracy and replicability and thoughts on N and issues of metadata, which are really data issues. I'm also going to talk about ethical issues, particularly attached to geolocational information like citizen science, VGIS, et cetera. And then I'll conclude by making a case for mixed methods and co-production. So just to point out, these are the big idea, NSF's current big ideas. These are 10 years of big ideas. There's 10 of them. 4 of them I think are really relevant to geographers. I'll mention 2 of them, and then 2 of them I'm going to talk about more. 2 are navigating the new Arctic. And the second one is the work at the human technology frontier, or the future of work. I think geographers have a good place to say something about that. But the 2 I'm going to focus on right now are harnessing the data revolution, thinking about how do we make data-enabled futures and how do we train scientists to use data. I think geographers have a lot to say about this issue. The second one is a process issue, and related to, I think, all of these other ideas, is growing convergent research. So what is convergence? To me, convergence is transdisciplinary research, but also needing to have other people at the table to solve society's big problems. So those other people could be citizens, those other people could be businesses. It's not enough to just have researchers do it, but we need to engage. And that's part of growing convergence. So some entry points I see for harnessing the data revolution in geography, things like research on and using new spatial data sources like drones, crowdsourcing, VGIS, GeoVis, social media, data sensors across spatial and temporal scales, which obviously have their own unique challenges. Another thing that I think geographers have a lot to say about is geospatial privacy, VGIS, citizen science, and ethics. These things are exploding ever in the natural sciences. Everyone tags everything, and everything has become the spatial information. I also think there's discussions about AI and machine learning that geographers have important things to contribute to. So now I'm going to go through some of my thoughts on these issues of big data and big N. So how big is your N? Mae West once said, too much of a good thing can be bad. Well, no, actually, she said too much of a good thing could be wonderful. This seems to be the sentiment of the times, especially in geography and related fields. During my first week of class, I presented data on a payments for environmental service scheme in a small community in the Amazon. And a grad student raised their hand and said, but your N is so small. This was true. And I was so taken aback. My small N of 40 households in a single community was small. However, there were less than 8 families in the community to begin with, even less involved in the PES scheme. And the households that were randomly selected and my small N stats were statistically significant. Diane Rocheleau, an ecologist and geographer, taught me the power of small N statistics. So some thoughts on accuracy and replicability. Permitting me the ability to generalize here and or sound outdated, or even like a Gen Xer who doesn't trust anyone. Large N data sets that are easily available on the internet have made a younger generation scoff at small N ethnographic fieldwork. At the same time, I know how my data was selected and collected and analyzed. My graduate students, suspicious of mixed methods approaches, are often happy to get all the data they need off of the internet in massive quantities. In my required mixed methods classes, I make them go to the field part of a required mixed methods design. So even if using data off the internet to go ground truth it, they need to go talk to people. Ethically, I believe when we interpret data that can have implications on communities, whether positive or negative, we need to see it for ourselves. And I brought up Kant here. He provoked us to dare to know, right? This is based on your own sense. This was the call of the Enlightenment. The Enlightenment was a turn away from religion or government telling us what to do, and instead knowing for ourselves. And that's the call of the Enlightenment. There's a danger of allowing data to become the new religion. Further, in the case of remote sensing, land use and land cover categories are far from clean, crisp boxes, being culturally created, constructed, and understood. Anyone who's worked in the tropics knows this. As researchers, we have an ethical obligation to understand these differences. Work by anthropologists and geographers, Joel Wainwright, David Salisbury, and others, illustrates the power of remotely sensed deforestation maps to tell the biased story of those making the maps, in that we make a series of choices that lead to the results that we want. For instance, is this traditional Swidden agricultural system deforestation, or is this something else? The answer depends on who you talk to, or does it depend on who has the most power? So when we grab information off the internet that is already completed, how do we know how these decisions were made? Such issues make a strong case for the importance of co-produced knowledge. I would argue that it's relatively easy to hide behind the power of a large N. Dennis Wenger, who was an ex-program officer at the National Science Foundation for Infrastructure Management and Extreme Events, basically the hazards community, once asked compellingly, do we really need more Twitter data, even if it's geolocated? Or 4 million tweets really better than 1 million tweets? And more importantly, who is left out of the sample? I believe that we have an ethical obligation to be more transparent about the data we're using and the potential bias, accuracy, and replicability issues, instead of hiding behind the power of a large N. In sum, I'm not really saying that we shouldn't use such data, but I am saying that we need to be more open and transparent and have more conversations about some of the issues around the big data. Now I'll talk about the continued issue of metadata and how this leads to data issues. In grabbing or scraping data off the internet, we continue to have ongoing issues with the data. My first question is graduate students who are excited about a database that they scraped or got off the internet is, where is the metadata? And do you trust the metadata? Often the metadata doesn't even exist. It might be outdated, or it might even be wrong. We talked about this issue in Billy Lee Turner's Land Use, Land Cover Change class all the way back in 2000. Amelia Moran and Eleanor Ostrom were talking about this at the SciPic Summer Institute in 2003. This is very important to global environmental change community, especially when you combine environmental data and human data, and I'm not convinced metadata issues have been resolved. Our continued metadata issues have implications, accuracy, producibility, and replicability. So, often these data sets come with little information regarding the collection, the methods, the accuracy of the data. An important point that I'm trying to make are metadata issues are data issues. And so I put this as an example. This is FOIable farm subsidy data by zip code. The Environmental Working Group has this on their website. It's really hard to get, and Environmental Working Group has FOIA'd it, won't share it other than through this interface. So a few years ago, I had a student scrape the data on farm subsidy data we work, and it produced certain results. I didn't really trust the results, but the results made logical sense, and it was better than not having the results. However, at the same point, a few years later, we had funding and we were to hire an RA to sort of reproduce this database very slowly. And pretty much every week, every question that my student had when we'd meet were about data concerns, about the data not looking right, or issues when people are attached to a zip code, but they're getting subsidies in a 5-state area. And so my point is, I wouldn't have confidence in the interpretation of this data unless I had spent the 10 years on the ground I spent. So these are tough things when we take data off of the internet, even if it's good data. Another issue that I bring up is geospatial data from GIS, crowdsourced, and citizen science approaches. There's ethical implications of all of this geotagged data. VGIS, crowdsourced, and CitSci approaches provide us with the ability to achieve large data for relatively low costs, and it's supposed to be monetizing science and helps with STEM education. These are all noble causes. However, we need to consider the quality of the data as well as the transaction costs in both positive and negative ways. From a science perspective, how do we ensure the quality of the data collected? What about the inherent bias of a self-selecting group of participants or data collectors? What are some ways to account for these issues? How do we balance the benefits with the known and potential challenges? How do we ensure that human subjects are protected and not exploited? So I've given you an example of Forest Watcher. This is a citizen science app that's very popular. It monitors deforestation in real time at 30-meter resolution and invites citizen scientists to go to the location and figure out what is going on. Yet across the world, there's forest watchers have been known to have violent acts done against them. In fact, forest watchers are sometimes killed for defending the forest. On the other side, for instance, marginalized and traditional peoples have historically fought for the right to practice small-scale sustainable swidden agriculture, and they're among the most marginalized groups. So that slide that I showed previously, small-scale agriculture. But agencies like the sheriff's office and police in the Amazon are actually using this to arrest people. So marginalized groups like traditional peoples, native peoples are now breaking the law in managing forests like for millennia. So what I'm reminded of here is Foucault's panopticon and power relations. And I ask, who will watch the watchers themselves? There's ethical issues here with the data we're producing. Another example that I'll give you is a personal example of the citizen science application eBird. eBird was produced by the Cornell Ornithology Lab. It's wildly popular. One time in the field, I was on a ranch with one of my colleagues who's very excited about biodiversity. I pointed up at a tree and I said, look at that eagle's nest. It was a bald eagle's nest. The eagle just had 2 baby eagles. The rancher was very excited about it. Without even thinking, my friend took out his phone, took a point of that location and started to upload it into eBird. And I said, what are you doing? And he was like, I'm recording this very exciting thing. And I said, but this is public information on private property. And we had this conversation. The person decided not to post that information. And then later we talked to the rancher. The rancher explained to us that information had already been posted and he couldn't get it taken down. And people kept regularly showing up on his property to look at these bald eagles, to the point that the bald eagles eventually abandoned their location. But also there's privacy concerns, there's health concerns. There were concerns that someone might get hurt on the property. This is sandstone, cavernous. It gives away on your feet. And so there's a slew of types of concerns that are wrapped around the implications of a simple GP point for both the birds and the owner. For me, if we're to involve people in work, we can and must do better. These kinds of issues lead to conflicts, and there's plenty of conflicts. Potential challenges in citizen science or VGIS, inherently biased samples, of replicability or reproducibility, issues of equity and potential exploitation, ethical considerations of participants, as well as the ethical consideration of the data collected. And I would ask, there's all these other things once you have the data or when you get the data from an open source. Who gets to decide what is shared, if it should be shared, when, how it should be shared? Seemingly innocuous and already public data, once made geospatial, can have profound negative impacts on different groups of stakeholders. And this is part of my argument for getting community more involved, thinking about co-creation of knowledge. Basically, in harnessing the big data revolution, I ask to remember that there are people connected to our pixels. So how do we ensure that human subjects are protected? And just for the record, most of the data that citizen science collects is biophysical, and IRBs are required, yet they impact people on the ground every day. Geographers are very aware of a lot of these issues, and I think on the forefront of these discussions as the naturalists start to use this type of data more and more, and the data revolution takes off. So my final conclusions, some final food for thought. Those of us who do and teach methods argue that different approaches can create more robust, reliable results. And the same can be said for co-production of results. And I remain acutely suspicious of getting all of my data from the internet. Perhaps I really am a Gen X. I still want to see for myself. I want to challenge people to know in that sense. More data doesn't always equal results. Sometimes it can overwhelm or even argument. In the end, I believe that as researchers, we need to be more transparent about the data we're using. I think we need to embrace scope and limitations seriously, yet we don't want to say that there's potential issues with data. We also need to ask ourselves who collected the data, how it was collected, and what might be the implicit bias, if any. And I also think we really need to think about how, when we make data spatially explicit, it might lead to potential ethical or human subjects concerns outside the foray of traditional IDs. But I think that the geographic community is the natural leader for a lot of these important ethical conversations. So I'd encourage people to get involved. I would note that if you go to a Citizen Science Association conference, there are barely any social scientists there, let alone geographers. There's lots of potential for these discussions to have geographers leading the way. Thank you.
Thank you, Jackie. There has been some great discussion points pouring into the question and answer, but they start to connect a few of the different talks. I think that we'll probably save those for the discussion section. But Jackie, in particular, there's been some comments about some good, I think, energy around who gets to decide what can be shared and when, as you noted. And you said specifically about kind of co-designing or kind of co-creating that. Can you potentially give us some tips on how we can make those co-design relationships happen?
I think we need to talk to people and talk to people in a reiterative way. So I'll give you an example. One of the databases we've been working on is a plat database. So we've been looking at changes over time back through the Dust Bowl out in the panhandle of Oklahoma. Plats information, you could go to the county assessor's office and get all of this information. It's public data. But when you make it spatial and you put it in easy GIS and anybody could look at it, there's a lot of very private kinds of information about property ownership. So we had a large debate on whether we should make this public or not. And we invited the public to join in, and we decided as a group and that not to make that public information. So those layers are available to researchers. They're available at the local museums, but people didn't want them available on our website because they didn't want their neighbors snooping on them. And that was not a decision we made, but that was rather a decision that we had after several community meetings. So, I mean, again, these are things that you could talk to people ahead of time, but then you have to talk to them again after you collected the data, because sometimes once people start to realize the power of the data, then they might change their mind. And so it's not about the data want to share the data with researchers and people that it's relevant, but also very cognizant that if we just post it on our website, all their neighbors will be downloading this data and they could see very personal information. Again, that's all information that they could get at the county assessor's office, but they'd have to spend a really long time getting that information.